Thanks, Nell. Appreciate it. So, shooting stars. Welcome, everybody. We're going to live code a game in 25 minutes or so-ish. Honestly, this presentation's about 45 minutes long, so this is going to be fun. All right. So, I love video games. I love making video games. But what if making a game felt like working on a Rust project? You know that feeling? Yeah. What's better than that? Well, Rust game engines like Bevy and others are bringing that feeling to us. And I want to share that feeling with you today. So my name's Nathan Stocks. Like Nell said, when I'm done with my day job, I teach Rust. I do Rust news on YouTube, and I make games. And today we're going to make a game. We're going to make shooting stars. It looks like this, just like that. We're going to have stars. There's going to be a field. And the shooting stars are going to fall from the sky, and Ferris is going to go and catch the stars. But not just that Ferris. There's also green Ferris and blue Ferris and yellow Ferris. All the Ferrises are going to catch the stars like this, right? He's going to go jump, catch a star, and then the yellow and the green and blue ones, hint, hint, will also go and catch the stars. And they're going to see who can catch the most stars. Catch the most stars, you win. And these are going to be controlled by live audience members in the audience. We've got 4 game controllers out here. Give our audience members a hand here. They're participating. So let's get going. So to begin here, we're just going to go cargo, new, shooting stars. Making this from scratch. I'm going to use VS Code for this presentation. There's lots of good choices. And go into presentation mode, open up our stuff. All right, now, like I said, we're a little pressed for time, so I'm gonna do what any good game developer would and cheat and grab a little bit of config here, and we should do this recursively. Copy that in, and we're gonna start stuff compiling because I'm on a laptop doing a live demo. This is gonna take some time. Let's look at what I copied in instead of typing really slowly. So I've got a config here to use a faster linker. I've got this config to use nightly, so it compiles a little bit faster. I've got these assets, which I was going to do live on stage, but it took too long. So we got this bling here. Bling. Yes, you can hear it. Yes, that's me in Audacity. That's when a star spawns. Then we've got this sound. Bum. That's when you catch a star. We've got Ferris here. Yeah, he's white. We're going to use the game engine to colorize him, tint him different colors. We've got this star here. You see my excellent developer art skills in Photoshop. Took me years to develop these skills. Anyway, he's going to catch these stars. They're going to come down. This is all going to be on this beautiful background here. Yes, I have the right license on the picture. Don't worry about it. It's all good. All right, and then we go to cargo here. We've got these different, oh my goodness. Don't tell me we don't have internet access. All right, people, tell me which one it is. I can read, yes. Oh, and the bone. How do you spell bonjour? Bonjour, Ferris. That's it.
Yeah, that's it. Lowercase, no spaces, no that.
Okay, this is going to be interesting, huh? It's on my It's on my lanyard. Got it. I'll tell you the one place I didn't do a run through, right here. Okay, let's see if we can get that going. Okay, it's going. There's our biggest obstacle of the day. Good, we've got our law of the demo out of the way. That's a good start. Okay, so what are we importing here? We've got our dependencies. We've got Bevy, the game engine. Yes, Alice, one of the core maintainers, is right here. Thanks, Alice. I bet we've got some more people here too. Thank you everyone who makes these awesome tools. We're using a physics plugin, an input manager plugin, also Alice's, a particle systems plugin, inspector plugin, a scoreboard plugin, a little utilities library that I wrote, and some random numbers. All super useful stuff for games. So let's go get started. Now, once again, I've only got so much time and I'm a slow typer and a talker, so we're gonna cheat and grab the boilerplate, assuming that my shell ever catches up with this. Thank you. Okay. So here's our boilerplate. This is really boring to type out. It's just a use statement for every single one of those dependencies that we had, and then we make a new Bevy app. We'll get syntax highlighting in a minute. I'm sure the laptop will catch up. And then we just set up each of the plugins. I'll come back to each of them and explain them as we use them. For right now, we're going to ignore them because what we want to do is we want to make ourselves a system, our very first system. So in Bevy, a system is a function, so we're going to add systems, add it as to the startup schedule, so it gets called just once. And we're going to call it setup. So a system is a function that the game engine calls for you under certain circumstances. So let's go ahead and write this setup function or system. So we're going to get access to some commands so we can spawn some entities. And we need access to the asset server so we can load files off of disk. And I'm really looking forward to my computer catching up and giving me syntax highlighting back. That'd be awesome. Yeah, but, we'll just keep on going. Hey, look at that, syntax highlighting. Okay, so Bevy's going to look at the arguments that we define in our system, and it's going to supply it to us. So it's kind of a form of dependency injection. It's kind of nice. All right, so what do we want to do? First thing in Bevy, if we want to see something, we need a camera. So let's make a camera. So we'll go commands, spawn, camera. We want a 2D bundle. We can use the default settings. That's going to work just fine for us. And now that we've got a camera, let's get something to look at. How about a background? Remember that background picture we had? So commands, spawn, and then we'll go name, new. Give it a nice, pretty name. Now, this is for the inspector. I'll show you that in just a minute. So it doesn't just say entity. And then we'll get a sprite bundle. The only thing we really care about is our texture because it's just a background image. Doesn't really need to do anything. So we'll get our asset server, load up our starry field JPEG. Great, and other than that, we should be fine with the defaults for now. Let's see if we're getting close. Close this one and go to the other one. Hey, finished our first compile. Now we only have to compile this project, not all the dependencies. So let's give it a try and see how we're doing. And I did something wrong already. What's my typo this time? Semicolon where? Last line, thank you. See that? AI in action. Okay. There we go. Excellent. So you can see we've got our scoreboard plugin giving us a little empty scoreboard. We've got our background showing up, but this background isn't quite the right size. It's too zoomed in. So let's fix that. But instead of doing trial and error and recompiling over and over, I've got this inspector plugin configured right here to pop up when I press the spacebar. So let's go do that first. Let's come over here, spacebar, there's our inspector. Yay, that's awesome. Find our background, get its transform. Okay, what scale does this need to be? Looks like about 70%, yeah, about 70% if I could get it right. So yeah, let's go ahead and put it 70% and see if we get it looking correct. So we'll come back here, say, okay, our transform here, transform. It's going to be a transform from the scale. We're going to give it effect 3 because this is a 3D game engine, but we're just using 2D. We're just going to go ahead and splat our 70% across the X, Y, and Z, and that should do it for us. So if we run it this time, it should pop up with the correct scale. So yeah, sometimes you do need to recompile, but the tooling's improving. We're getting closer and closer to having real editors. Look at it, looks correct. And pretty soon, instead of using plugins, we're going to just be, doing all the other stuff to go and check and see if it's the right rotation or what have you and stuff like that. Okay, great. So we've got a background. That's fantastic. Let's get some stars appearing. Spawn the stars, have some sound effect play, have the star fall down, and let's give it a nice particle system. How about that? I like particle systems. They're just so juicy. All right, let's take a look at our physics plugin. So I set the physics plugin to 200 pixels per meter. We've got a 64 by 64 Ferris. That's going to give them about a third or a quarter of a meter. So that should be about the right scale. We've got this physics debug rendering plugin that'll give us wireframes, but I set it to be disabled by default. So we'll use that same inspector to go and toggle it on when we want to see the wireframes. But there's nothing to see yet physics-wise. So let's come down to our setup here and create some gravity 2D boundaries. Give it a mutable command here. Now this is just a little utility that I wrote so that whenever I just want some boundaries on the edges of my screen, instead of having to type all this out, I can just call the function. And I mean, really, who wants to watch me type all the numbers out? Nobody. So if we go and run that, we'll see absolutely nothing at first because we haven't turned on that plugin. So let's go to our resources, go to our debug render context, turn that on, boom. Okay, so there's our physics edges. In fact, if I make this a little bit bigger, you can tell that they're just these rectangles that are overlapping. To keep Ferris, we can put Ferris here, and he won't fall out of the world, right? That's good. Want Ferris to stay in the playing field. All right, next up, let's make our stars. So we need to go ahead and define a component. So in Bevy's ECS, so something in the game world is an entity. A component is something attached to an entity. You can think of it kind of like a tag. It's just going to be a struct that's going to be a star. We're just going to say, hey, this is a star. This is kind of like a tag because it has no data. We also need some way to know when to spawn things. So I'm going to make a resource. Resource is like a global variable in the game. So we'll say, okay, struct, we'll call it star timer. Time when we're going to make our timer. And this is just going to be a new type of timer. And then we can come up here, and we need to actually add that global variable. So we'll go insert resource and make our star timer, which is a new type of a timer, and go from seconds. So we're going to just put it at 0, so we just instantly get a star spawning when we start the game. And we're going to set our timer mode to repeating. But every time it repeats, we'll go set it some random values, so that 0 is not going to be a problem. All right, we did that. Let's go ahead and add now some update systems. So these systems are called once every frame. It's going to be a bunch of them, so I'm going to make a tuple here. First thing we want to do is spawn the star. So we'll call it spawn star. And since I can't type and talk fast enough, I'm going to go ahead and cheat and get the boring part of spawn star. All right, here it is. So we're getting commands so we can spawn things. We're getting the asset server so we can read files off disk, the star timer so we know when to spawn a star, and the time so we can tick the timer. And that's everything we need. So let's get an alias to the random number generator because we're going to be using it a whole bunch in this system. Now let's check our timer here. So we've got to go star timer. We've got to get the inner timer. We need to tick it because it's not just going to tick itself. Give it our time delta. Great. And then we can check, did it just finish? If it did, great, time to spawn a star. So first, let's set a timer for the next star because we really don't want to forget that. If it stays at 0, we're going to get a heck of a lot of stars. So get a duration from, let's do F32. Okay, now we'll use our random number generator to generate a number in the range from 0.2, be really fast, to like 2.0 seconds for 4 players. That'd be a little bit slowish. Somewhere in between there. Then we'll take our star timer, get its inner timer value, and then set that duration to the duration we just did, and we're ready to actually do star spawning stuff, like playing the sound. So let's play a sound, give it access to commands and the asset server here. Now this is just a little utility function I wrote because I want to play sound effects the same way every time. And I didn't want to type out all this. Let's take a peek. I just didn't want to type all this every time. It's a little bit verbose. Yeah, we could get some tooling support, but hey, we're getting closer. And then let's actually spawn the star. Spawn the star. Now this is also just going to be a whole bunch of settings, so let's speed this one up as well. So I'm going to go cheat, chunk, spawn star. Great. Put that in. Let's go over this. Okay, so first thing I'm putting in is a name, so it doesn't just show up as entity under the inspector. A star, so we can find it in ECS searches. Sprite bundle, we're going to load up star PNG. We're going to give it a random location somewhere in the middle 2/3. We're going to put it up at the top, like off the top of the screen. We're going to say, yes, you're participating in physics. You're going to move. You're going to emit collision events, but you're going to be a sensor. So instead of bouncing off of things with physics, you're just going to overlap. Your physics collider is going to be the shape of a ball. In 2D, that's a circle, radius 28. We're going to turn off gravity because it fell too fast to actually go and catch it when it was falling with gravity. So we're going to give it a slower, like fixed velocity, but it's going to be a random fixed velocity, a little bit of drift to the left and the right, down quite a bit faster, and then some kind of random turning at negative 1.2 radians per second to 1.2 radians per second. And the last, but definitely not least, the particle trail, my favorite part. And this, I put in its own little function so I can use it whenever I want to and not have to remember all of the settings that took me a very long time to figure out. So that's our star, and at this point, we should be able to spawn our star and like see it all working. So let's load this up. We should see the stars appear at the top. Oh, there's our sound effect. Bling, bling. Oh man, that sound effect artist is amazing, isn't he? Look at the particles trails. Oh my gosh, so juicy. I'm loving it. I'm loving it. Now, let's look at it in here. You can see fuzzy match here on our stars. See, they're all showing up and never going away. In fact, if we look down here, there's going down to negative infinity. Oh dear. Okay, so let's go and clean that up next. Clean up the stars. So to do that, we'll just come up and make a clean up star system. This can be a relatively simple system. We'll just go clean up star. We just need our commands so we can despawn the star. We need a star query. So this is our first query. It's analogous to a SQL query, but different because it's querying an ECS. We want an entity and a transform. You can kind of think of that as like the columns we want. We don't want it with the star component. It's kind of like saying, well, it's in the star table, but different. And then all we need to do is loop through it so far. Star entity and transform in the star query. Okay, we want to clean up the star if it's off the bottom. So we're going to look at the transforms translations Y value, and if that's off the bottom, so past about 400 pixels, it's off the bottom, can't see it anymore, go ahead and clean it up. So we'll go commands entity star entity and just call despawn recursive. And that's it. That should get us cleaning our stuff up. So let's take a look and see if we did it right.
Bling.
Okay,
Bling.
check here, look at the
Bling.
stars. Do they clean
Bling.
themselves up? Yes.
Bling.
And we should be able to see that visually.
Bling.
Perfect.
Bling, bling.
Bling, bling. All right, so next up, we got our stars. Let's get the player in here. We need a game at the end of 25 minutes, so let's get going. Let's derive another component. This time it's going to be our player. Now the players do have differences and want to keep track of at least their ID. So we're going to make an ID and make that a usize. And then up here, we're going to use this input manager plugin to map input from the gamepads to actions. And we're going to use this scoreboard plugin and add players to the scoreboard. Now this action enum is just an enum with jump and run. I just made it, and I said, okay, jump is going to be some kind of button. Run is going to be some kind of axis. Think joystick, all right? And we need to come make a system for that. So make a join the game system. We'll just call it join. And then I'm going to cheat and get the boring part. All right. So we're going to have commands so we can spawn things, ask the server to read files off disk, the scoreboard so we can add the players to the scoreboard, and the gamepad connection events. Because when these gamepads connect to the game engine, we're just going to use that event as a, oh, you want to be in the game? You're in the game. So nice and simple. So we'll just go for event in gamepad connection events, read through those events. And then the event could be disconnecting rather than connecting, so we're going to go if event disconnected. Now here is where like we would do all of our nice handling like exiting the game, but we don't have time, so we're going to skip it. We're going to set up input. Say our input map is input map. I'm going to start with the defaults, and then we're going to go ahead and say, okay, we're going to take our jump, so that's action jump, and that needs to be a gamepad button type. Remember we talked about that? And we want it to be our south button, not select, south. Okay, so south button on an Xbox controller is the A button. Okay, so that's going to be our jump control. And then we've got with axis. So this is going to be our run, our joystick that lets us run. That's going to be our gamepad control axis. This is going to be the left joystick's X axis. That's what we're looking for. And then we're going to give that with a symmetric dead zone so we don't get drift because, I mean, I don't know about your game controllers, but yeah. Then we'll go with gamepad, and this will bind it to the actual gamepad that it joined in this event. So we're going to take the actual physical stuff that happens on the gamepad, we're going to map it to these enum actions that are going to stick to our entity. And then in the next step, we're going to then bind those actions to different physics that actually moves the player around. So we're just about ready to spawn our player. We do need a couple little things for the player to have before we spawn them. So we need an ID. Remember that ID that we decided we were going to have? Lucky for us, the gamepad has an ID, and we're just going to steal it. And then we need a unique color, and it just so happens that I have a utility that if you give it some ID number, it'll give you a unique color. And then we need a name, so let's say format. And obviously, the name's got to be Ferris, but we'll put on the ID, so Ferris, whichever number. And then we can go ahead and add our player to the scoreboard, so add player to our ID, name, color. Great, and then we do the actual spawning, and since I'm not typing fast enough, we'll get our chunk for spawning the player, put it right here, let's go over it. So we'll give him his name, we'll give him his player and ID, we'll give him that input manager bundle with the input map that we defined, we give him the sprite bundle, we colorize the sprite by the player's color, we give him some random location all across the bottom, near the bottom, and we use the Ferris PNG, yes, he's going to be moving in with physics, we turn linear damping way up, so when you stop moving him, he stops pretty quickly. We're turning his restitution really high, so if a Ferris touches another Ferris, they bounce quite a bit. We got his 28 radius circle collider, and then we got the velocity and external forces that we're going to use to actually move him. We're going to apply those forces to move him, and then we've got to set his mass to 1.0 because the physics engine gets super cranky if you don't have any mass on the object you're applying force to. Don't know why, it's just kind of the way it is. All right, and that should be enough to get us going and having, oh yeah, I'm gonna do a reference here. Let's do that. Ownership model, it's a good thing. Okay, so this time, if we got
Bling.
Xbox controllers on, you can see they connect. We haven't mapped the physics
bling.
forces yet, so they
Bling,
can't
bling.
move, but they're there.
Bling.
I promise they're there. Okay, so let's go ahead and add our movement system and do that mapping. So we'll come up here to the top, add a movement system, and then speed this up a little bit, grab the boring part. Okay, movement system. This is just one big query, kind of like a SQL query, but it's getting the actions that have been emitted for this guy, and then it's got the velocity and external force. So velocity, so we can give him a jump velocity when he presses the button. External forces to go left and right. Transforms just so I can know where he is in case I want to make it so he can't double jump or whatever. So we'll just loop through the actions, the velocity that we need to change, the external force that we need to change, the transform that we want to look at in our mutable action query. All right, and then the first thing we want to do is handle the running. So get our external force, get the force component. This is a 2D game engine, or 2D physics, I should say, that we're dealing with at the moment. So we're going to give it a vector 2. The x value is going to be our actions value for the action run. So that's going to be from -1 to 1.0 for the value of the joystick, which is not a big enough number. So we're going to go ahead and multiply that by 1,000 so we have some real forces in play. And then nothing in the y direction because running's just left and right. Jumping is for up and down. Here, it's almost as easy. We'll just go action. If action was just pressed, check for our action. Jump. There we go. And then if we're going to crack down on jumping forever, we'll say, okay, you have to be down near the ground to be able to jump. So if your translation .y is also less than about -315. Okay. And then we can say velocity, linear velocity, and his y value is going to be, set it to 1,250 pixels per second. Gravity will pull him right down, so that'll be a nice, good jump. And now, our players should actually be able to move around. So let's check it out. Should be able to move around, but they're not actually able to catch the stars yet.
Bling.
All right, can we move? And
Bling.
yes,
Bling.
we got roly-poly
Bling.
Ferrises
Bling.
because I
Bling.
didn't lock my
Bling.
rotation.
Bling.
We could do that, but hey, it's
Bling.
kind of nice, so we're just gonna let it go. I kind of like it.
Bling.
Look at that.
Bling.
They're bouncing.
Bling.
Very collaborative. Let's make it so we can actually catch the stars. This is our very last step. After this, we're going to be done. So we'll see who wins. We need to catch the stars. So we're going to add a catch star system. Speed this up. We'll go cheat catch star. All right. Okay, so we've got commands so we can spawn or despawn, asset server so we can access files, the scoreboard so we can adjust the scores. We've got collision events because that's how we're telling that Ferris and the star are overlapping. And then we've got a bunch of queries to kind of sort out what's what in those collisions. So let's go ahead and just go through it. So we're going to say for event in collision events. Go ahead and read through those events. And then we're going to do a little bit of pattern matching here. We're looking for a player entity and a star entity. And I have a little utility function called collision started that I wrote that takes a player query and a star query, and it does all of the really boring logic to figure out which entity is which and return them in the right order from your event. And we know that if we get to this spot, we have just a player overlapping a star, and we know which one is which is exactly what we want. So we're catching a star, so let's play that sound. Play sound. All right, mutable commands, get our asset server, file name, and this one is bomb. And then our volume is a quarter, which is still nice and loud in this venue. And then we'll increment the player score because they caught a star, so increment the player score. So we need to get access to that player component that we did. So we'll go player query, get player entity, unwrap, because that would never, ever go wrong for us. We know it's there for sure, right? You know what I'm talking about. All right, and then we'll take this player ID, increment the score by 1. Now, if you had different color stars that were worth a different amount of points, we could handle that right here, but we don't have time for that kind of thing today. Then we say, did the player win? Because he just got a point, he might have won. So if scoreboard get score for this player ID, and let's just put it to 5 so it doesn't take us forever to have a winner here. Scoreboard, show winner screen. It happens to have a little winner screen so we can just tell it which entity to display its sprite for. And then of course we need to remember to not despawn the star, or we need to remember to despawn the star so we don't catch it over and over and over. So I'll go commands, entity, star entity, despawn recursive. And last but definitely not least, we need a particle poof. So it just looks awesome, which is like a okay? So I just happen to have a little spawn particle poof utility here. And we need to give it some place to spawn it. We want to get the stars transformed, so that's what this other little transform query is for. We can say get our star entity. Now, even though we've scheduled it to be despawned, it won't actually be despawned until the end of the frame. We're just scheduling these commands to happen, so it's still there to look at. So we're all good, and that's it. All right, so now it is up to these fine folks who have volunteered to see who will win this game. Okay. Oh, we got Green Ferris is off to an early start. We got Blue Ferris coming up behind him. We got some bounce. This is a non-violent game, folks. All right. Yeah. Oh, Green Ferris. Give it up for Green Ferris.